This is Mr. Anderson for Kellogg Community College, and I'll be taking a look at page 137, problem number 6, in section 3, part 2 of the Blumen Elementary Statistics book. The question asks in problem 6, these three data sets have the same mean and range. But is the variation the same? Prove your answer by computing the standard deviation. Assume the data were obtained from samples. Well, I'm just going to give you a quick spoiler alert here that no, these do not have the same variation. You can probably see that, but it would probably be best to prove it by using the standard or finding a standard deviation. So let's go through and show you how to find a standard deviation by hand of data set A. Now the first thing we should probably do is create a little table, and I like to create the table vertically. So let's go put one of each data piece down on our notebook paper using one digit per row. And this is our actual data set, or our data set X. Now what I'm going to do is add up all these numbers and divide by 1, 2, 3, 4, 5, 6, 7 and see what I get. Now if I add up all these numbers, so the sum of our data set here, it adds up to 77. Now if I then divide by 7, I get my average, and my average is going to be 11. So the average of this set, which is my second column here, is going to be 11 for each one of these. Now this might deviate a little bit from the book, because what I like to do is my next column is going to be my deviation from the mean. And I think of my deviations as distance from. So I think about how far is 5 away from 11, which is 6. 4 from 11 is, or 7 from 11 is 4. 2, 0, 2, 4, and back to 6. So you can see that each of these have kind of a nice little symmetry right there. That's our deviation from X. Then what we're going to do is we're going to square, take whatever we have here, and we're going to, so deviation from the average, we're going to square that. So this is 36, this is 16, 4, 0, 4, 16, and 36. Now what I'm going to do with all these deviations, I'm going to take the square deviations. Now I'm going to add that up. So 36 twice, 16 twice, 4 twice, and 0 once adds up to a total of 112. So this is the sum of the squared deviations. What I will then do is take that 112 and divide by n minus 1. So my total in this case, my number of numbers, was 7. So my n minus 1 is going to be 6. So 112 divided by 6 is 18.6 repeating, or 18.7. Now, if I've taken that and now I'm going to take this answer here, this 18.7, and take the square root of it, and that will give me my standard deviation. So 18.7, which I've rounded for the square root. I know you could type in 18 2/3 and get a little bit more accurate answer than I am getting, but my standard deviation is going to be approximately 4.32. And that's how we find our, 4.3 if we're actually doing our boundaries correctly. So this is my standard deviation of set A. So set A standard deviation is 4.3. Now to verify my problem, I can check on my graphing calculator and do it pretty much by data entry. Make sure you copy this down, because what I'm about to do next is going to have this disappear. Poof! And so let's show you how to do this on a graphing calculator. Now, please note that on the test, I will have you do it both ways. Once on the calculator, once on paper here. So you type in your 5, 7, 9, 11, 13, 15, and 17. This data set was uniformly spaced, so its variation is also very uniform. So let's go now, click Stat, click Write, and we want the one variable stats, so click Enter. And one more time, unless you have a newer version where you'll have to scroll down and hit Calculate. And there it is. Notice that here, this capital letter S, X, is the standard deviation for any data set size that's that's under 30. So this is how I check my answer, 4.32, which is what I got. So that, my friends, is the standard deviation for the set. So before I forget it, I probably should write it down. So if I'm going to go back here, I should probably put that my standard deviation is 4.3. Now, I would like you to practice by pausing the video here and doing a standard deviation by hand, and then I will use the technology to run the standard deviations, and we'll get our two answers. And I'm not going to do, of course, this all by hand each time, but if you still struggle with that, please let me know in an email, and I'll see what we're actually doing here. So unpause the video when you're ready, when you have these two answers done by doing the standard deviation by hand, and we'll check our answer using our calculator. Okay, let's bring the calculator back. Here it is. Now if I click Stat and Enter, I can change this data set. 5, 6, 7, 11 still there, and then 15, 16, and 17. You can see that this data set is actually like less centered in the middle. Like there's like these numbers are close together and these numbers are close together. So if I go Stat, Right, 1, Enter, you'll see that my standard deviation is now 5.1. So what I want you to do is now kind of guess what you think is going to happen here with this data set. Will data set C have the biggest standard deviation, or will it have the smallest standard deviation, or will it be somewhere in between these two? Run your hypothesis. If you've done the work already, you already know the answer. So here I have 3 5s, the 11 in the center, and then 3 17s. All right, so we are now going to go Stat, Right, 1, Enter. And you see that this has the greatest standard deviation of 5.6. And that makes sense because the group is definitely more varied with very heavy weights on the left and right side there. So this proves by doing the standard deviation 3 times. Oh, shoot, I looked at the wrong standard deviation here. Sorry, my standard deviation is 6. Sorry, I gotta make sure, and I did a mistake that will sometimes get you in the same places where you accidentally take a look at the wrong standard deviation. Look for the capital letter S. Look for the capital letter S because the capital letter S is a standard deviation you use for a small number of data set pieces, usually under 30. And this is what you would use for a large number of data sets. So again, 6 is the correct answer. So this, my friends, is the standard deviation. And it's the biggest, has the biggest variation of the data sets. All right, now if you have any questions by doing part B and C by hand, just let me know and I'll email you back and see where we're making mistakes there. Thank you for watching.